All right. So let's discuss Lewis structures once that goes away or not. There it goes. All right. So Lewis structures are based on the valence electrons. We're now going to use what's called the Lewis dot structures. Every valence electron is represented by a dot, and we use the north, south, east, and west areas of the atoms. And it is sort of best to distribute one electron to each side and then start distributing a second electron to each side. So basically, um, since the number of valence electrons maxes out at 8, you would have 2 on each of the 4 sides for noble gases. Things with one fewer electron than noble gases would have one by itself on one side. Things with 2 fewer would have 2 things by itself. Things with 3 fewer, 3 things by themselves, 4, right? One thing by itself all around. So these Lewis structures are important in showing those S&P electrons. Remember, you have up to 8 total valence electrons, and it helps with drawing valence Lewis dot diagrams. So recall that silicon, which has the atomic number 14, is 1s2, 2s2, 2p6, 3s2, 3p2. These threes refer to the outermost electron shell, right? The outermost shell, there's a total of 4 electrons in there. That's why it has 4 valence electrons. Bromine, which is number 35, is everything argon is 4s2, 3d10, 4p5. Again, the 3d is the shell below the 4, so that's going into the third shell, while the fourth shell does have electrons. So the valence electrons are only in the outermost shell, this fourth shell. So that's a total of 7. So Lewis dot wise, you would put 7 dots around bromine, right? 1, 2, 3, 4, 5, 6, 7, and that would reveal how there's one area that bromine's looking for an electron. Okay, so there are these things called diatomic molecules, and diatomic molecules are atoms that like to exist as pairs when given the freedom of being just in their elemental form. So when you have 2 oxygen atoms or 2 nitrogen atoms or 2 hydrogen atoms, they tend to just jump and bond with each other. And this is basically for 2 reasons. One has to do with the fact, think about hydrogen, right? Hydrogen has a proton with an electron, and then another hydrogen is formed with a proton electron. Well, those 2 electrons want to get together. Hydrogen wants to be like helium. And by sharing these electrons covalently, now they feel like they're helium. So as soon as 2 hydrogen atoms come together, they will quickly bond with each other. It's not going to be true with like copper or magnesium or aluminum or a lot of other atoms. But for these 7 things, they tend to form these diatomic molecules. So there's 2 ways to sort of remember which of the 7 are. One is that, hopefully it just makes sense, hydrogen, fluorine, chlorine, bromine, iodine, they're all one away from noble gas. So when 2 of them come together, so here's a fluorine atom with its 7, and here's another fluorine atom with its 7, it should make sense that both being one away from a noble gas would just bond. So halogens, hydrogen all do this. Oxygen and nitrogen being such high electronegative atoms, they will just do it. And nitrogen, in that case, makes a triple bond. Oxygen makes a double bond. And we'll start making some sense out of that here. Another way to remember it. So there's 2 ways to remember these. One is starting with atom number 7 or the atomic number 7. They actually make a 7. If you see there, that looks like a 7. The problem with that memory device is you have to remember hydrogen is also involved in it because of those 7 hydrogens not there. This is a word that some people use to remember it. Brinkelhoff, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. So the letters of all the ones involved, the 7 involved, spell the word Brinkelhoff. So if that makes sense to you, remember that. If the 7 makes sense to you, remember you also have to remember hydrogen's part of that. But those are the diatomic molecules, and that's a nice entry into Lewis structures. Now, Lewis structures happen because of the desire to be like noble gases. So this method here, I'm actually not going to get into right now. Let's think about water. There's two ways to do this. If you think about water, oxygen has 6 valence electrons. So we're going to go 1, 2, 3, 4, 5, 6. Like I said, go around to every side first and then start putting another one. And then here comes hydrogen with its 1. And here comes another hydrogen with its 1. And hopefully it makes sense to you that these lonely electrons are the ones that are going to want to pair. Hydrogen, being one away from helium, wants to share an electron with oxygen. So those two are going to share. And this hydrogen now thinks it's helium because it has 1, 2, and it has 1, 2, right? So these two hydrogens now think they're helium. Whereas oxygen, with this sharing of electrons, now thinks it's like neon. It has 1, 2, 3, 4, 5, 6 originally, and now it has 7 and 8. So it thinks it has 8 electrons. Hydrogen thinks it has 2 electrons, and that's how that happens. Now, the other way to do it is this method of adding up the valence electrons and distributing them evenly. This method actually does maybe resemble what happens more toward what our understanding is. But let's go back to the list of rules. The key rules here is determining the central atom. Now, the central atom, the one that's going to be in the middle, is going to be the first listed unless it's hydrogen. Hydrogen makes an awful first central atom, but it's sometimes listed first for acids. We learned that already, I think. Maybe not. But so here, water, H is listed first. It makes an awful central atom, so you're going to put oxygen in the center. The other thing that I like about this is you adjust for charge. This is a good rule, right? If something has a positive charge, you would take away an electron. If something has a negative charge, you would add an electron. So let's get into that a little bit here. So nitrogen with 3 chlorines. So nitrogen has a total of 5 valence electrons. So we're going to put 5 electrons around nitrogen. Oops. There we go. And then chlorine, that's the central atom because it's the first one listed. And then we'll do chlorine. And I think chlorine's more of a green. So if you think about what chlorine has 7 valence electrons, right? 1, 2, 3, 4, 5, 6, 7. And you see how this electron's all by itself and this electron's all by itself. So they're going to want to get together and bond. So now chlorine thinks it has 8 and nitrogen thinks it has that one. And since there's 3 chlorines involved, we're going to do that on each of these sides with a lonely electron for nitrogen. All right, so there's 2 electrons coming together. And then here's the third chlorine, again, 3. So that's where I'm getting that 3 from. The 7 valence electrons are in green. So the lonely ones come together. And that's sort of the key to drawing Lewis structures. Carbon dioxide, so carbon has 4 valence electrons. It's listed first, and it's not hydrogen, so that's going to be the center one. And it's got the 4 valence electrons, 1 on each side. And now here comes oxygen, and oxygen has 6. Now there's 2 oxygen atoms, so one will be on one side and one will be on the other side. And we'll put those electrons all around. 4, 5, 6. So that has 6. And then the same thing here. Bear with me, I kind of know what's happening in the next step. So do you see how this one's alone and that one's alone? So they'll share. This one's alone and that one's alone, so they'll share. This one's alone and that one's alone, so they'll share. This one's alone and that one's alone. These are already paired up. These are already paired up. these are already paired up and those are already paired up. So they weren't looking for friends to share with. Just the ones that are all alone are looking to bond with someone else. And now again, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So it thinks it has 8 electrons like a noble gas. Carbon has the 4 blue ones plus the ones it's sharing. So 5, 6, 7, 8. So now carbon thinks it has 8 valence electrons like a noble gas. All right, so I do kind of like that better. Notice at the end of the day that if carbon has 4 valence electrons, it needs to make 8. That means it'll need 4 more bonds to form an octet. And the other way to think about that is, right, carbon's going to have 4 lonely electrons, so each one needs to bond. Nitrogen is going to want to make 3 bonds because it has 5 electrons. There's 3 places here, 1, 2, 3, where it wants to bond. Oxygen has 6 valence electrons, so it should make sense that oxygen has these 2 places that it wants to form a bond and be like a noble gas. Halogens will have 7. So there's only 1 lonely electron, so only 1 bond it needs to make. And hydrogen, please remember, hydrogen only makes 1 bond. It has 1 electron. It's trying to be like helium, so it's only going to share 1 electron to have 2 total. All right, and again, we have the bonding pair, which are the ones in the middle between the atoms, and the lone pair are the ones that sort of the atom brought along with it. So that is how you do Lewis structures. Lewis structures, remember, the center atom is the first listed unless it's hydrogen, and you're going to use valence electrons to figure out where everything goes.